All right, guys, here is 2012 number 3 that somebody had asked about. I'm going to post this on both AB and BC since this is actually on both of your Bibles. So let's get going. So first question says, or the question says, let f be a continuous function defined on the interval from -4 to 3. You're including -4 and 3, whose graph consists of 3 line segments and a semicircle centered at the origin. So that's really important that you have to know that that's a semicircle right there in the middle, is given above. Let g be the function given by g of x equals the integral going from 1 to x of f of t dt. All right, important stuff here. So now, A, you got to find the values of g of 2 and g of -2. Okay, well, you're plugging that in for x. So if I look at g that's up there, that's the integral going from 1 to 2 of f of x dx. Now we just need to remember, what does integral mean, right? Integral means two things, either area under the curve or antiderivative. What do we have here? We don't have a function to take an antiderivative, but we do have a graph where we can figure out the area under the curve. Now remember, area under the curve just means the area from the x-axis to the curve. And in this case, I'm going from 1, which is over here, to 2, which is over here, which means I'm figuring out that shape right here, which is a good old triangle. How do you figure out the area of a triangle? 1/2 base times height. So in our case here, 1/2, the base is going from 1 to 2, so that's 1, times the height. Now, here's the thing. This is not a unit of 1. That's -1 right here, over here. That's 1. This is in the middle, so that's really a height of 1/2. Right? So 1/2 times 1 times 1/2 is 1/4, but also look at where my area is. It's under the x-axis, so it's going to be negative, so that's -1/4. Now let's do g of -2. So again, I'm going to do the integral. I'll do this in a different color so not to confuse you guys. Going from 1 to -2 of f of x dx. So now I'm starting here at 1, but I'm going all the way here to -2. Now, I'm going backwards. You see that? I'm going from right and I'm going to the left. That means everything reverses. Got it? So that means any area below the x-axis is now positive. Any area above the x-axis is now negative. Got it? Or if you wanted to, it's really, remember, the negative integral going from -2 to 1 of f of x dx. That was our very first rule with integrals, right? So let's figure this out. So first off, this area right here, they told us it's a semicircle, the radius is 1. Well, how do you figure out the area of a circle? Area of a circle is going to be pi r squared. If it's a semicircle, I'm just going to divide it by 2. It's half a circle, right? So in our case, that's pi times 1 squared over 2, or just pi over 2. But because it's now under the x-axis and I'm going backwards, it's going to be positive pi over 2 plus, now I got to figure out the area of this triangle right there. Now, that base is 1, that height is 3, right? Area of a triangle is 1/2 base times height, but wait, it's also going above the x-axis, but we're going backwards, so it's really negative. So -1/2 base of 1, height is 3. So you can just write this as pi over 2 minus 3 over 2. And there you go. This was 2 points right there. 1 point for each answer. So very straightforward. Just the stuff that we had just ended the semester, or started the semester with before all this craziness happened. All right, let's look at part B. For each of the derivative at -3 and the second derivative at -3, find the value or state that it does not exist. All right, This is interesting. So remember, this is g of x. We need to remember that, right? So when I am taking the derivative of g of x, what am I doing? Is I'm taking the derivative of the integral going from 1 to x of f of t dt. Fundamental Theorem of Calculus, Part 1. This was the very, very easy thing on the very last test, that Chapter 6 test that we did, where I said, hey, you guys aren't going to like this. You all said it was super, super easy, and then you forgot it on the test. What happens to a derivative and an integral? They just cancel out. So all the derivative is f of x, and now plug in -3. Well, that's f of -3. Well, what's f? F is the graph. So it's just saying, go to -3, that's 1, -1, -2, -3, and go up. What is that? That is 2. And there it is. Now, we got to take the second derivative of g of x. Okay? Well, the second derivative of g of x is just the derivative of f of x. Right? If the first derivative of g of x is f of x, I got to take the derivative again. That means that's just the derivative of f of x. That means I got to take the derivative of f. I got to take the derivative of this graph. Well, what is the derivative? What does derivative mean again? Derivative means slope at a point, right? This is why we really like this question, and this is easily why this question can be on your AP test in a couple weeks, guys, is because it's bringing things, definitions of derivative and antiderivatives and area under the curves and slopes, and putting it all together, right? So I got to figure out the slope here at -3. Well, we all should know how to do slope. It's going to be rise over run. So our rise is 1, 2. Our run is 1, 2. It's a positive line. It's going to be 2 over 2, which just equals 1. And there you go. 2-point problem for that. Don't make these harder than it is. Think about how I asked these questions. I asked, okay, what does derivative mean? What happens to a derivative and an integral? What did integral mean? What happens when I take a derivative and a derivative? You have to ask yourself these vocab type questions to help you get the answers right. All right? C. C is a little bit more difficult. Find the x-coordinate of each point at which the graph has a horizontal tangent. All right, horizontal tangent. So you have to think about that. Horizontal tangent line means that the slope equals 0. That's a horizontal line, right? For each of these points, determine whether g has a relative minimum, maximum, or neither. Well, think of it. Okay, interesting. So, well, why are these connected? Well, let's think about it, right? How do we find a minimum, a maximum at all is you find critical points. What happens at the critical points is you take the derivative and you set the derivative equal to 0. Well, that's the slope. Derivative is slope. Slope equaling 0, right? So, so they're kind of putting this all together for us. Okay, so if I've got to figure out where the slope equals 0, that means I got to figure out when the derivative equals 0, and it's the derivative of g. Well, we just did this, right? We just did this in part B, because what happens to the derivative in an integral, again, they cancel out. So really the derivative is just f of x, and I got to take f of x and set it equal to 0. Well, what's f of x? F of x is our graph. We just got to figure out when does the graph equal 0. Well, this occurs only at 2 points, right? At x equals -1 and x equals 1. Now, we got to figure out here at each one, is it a maximum or a minimum? Well, what happens here? Remember, this is the derivative of g. F of x is my derivative, right? So after you figure out the critical points, you kind of make a sign chart. We can kind of do it in our head and figure out the sign of the derivative. Well, before -1, the derivative is positive. After -1, the derivative is negative. So that means it goes from positive to negative. That means the graph is increasing, then decreasing. We have a maximum. So you can say, just a sentence, right? G of x has a local or relative, doesn't matter, maximum, do not abbreviate, write the word maximum, at x equals -1 because, and now what's our reasoning? It's just what we said, kind of the sign chart. The sign, this is an S by the way, the sign of the derivative of g of x changes from positive to negative. There you go. All right. Now, let's look at +1 here. Well, before +1, it's negative. After +1, it's still negative. The sign of the derivative never changed, so there isn't a maximum or a minimum. So you could say at x equals +1, g of x doesn't or does not have an, you can say extrema if you want, because the sign of the derivative, g prime of x, this is g of x by the way, sign of the derivative didn't change. Boom. One sentence, no pronouns, explaining all of it. This was 3 points out of the 9 right there. 1 point for figuring out that the derivative equals 0, right here. That was 1 point. 1 point for figuring out that it happened at -1 and 1. And 1 point for your justification. Got it? All right, last one. Part D. From -4 to 3, find all the values of x for which g has a point of inflection. Explain your reasoning. Okay, so now let's think back. A point of inflection. What does a point of inflection mean? Point of inflection is when the graph's concavity changes, where a graph changes from concave up to concave down, or the graph changes from concave down to concave up. Okay, what tells us concavity? The second derivative, right? So that means we got to look at the second derivative. You set it equal to 0, and then figure out that, yeah, we have to take a second derivative, set it equal to 0, and see if the second derivative changed sign at those possible points of inflection. And if they do, those are the points of inflection. Okay, so now again, let's think of second derivative. Second derivative of g of x means, you know, you're taking the derivative of the first derivative of g of x. Well, we already know the first derivative of g of x is f of x, so that means it's going to be f prime of x. That means it's the derivative of the graph. And what does derivative mean? Derivative means slope. I am looking at the slopes of this graph. And whenever the slope changes sign, that is a point of inflection. Got it? So let's see. Here the slope is positive because the graph is increasing. Here my slope is negative because my graph is decreasing, right? So that means I've got a point of inflection right here at -2. Still negative here, and then it's positive here. These would be all positive slopes. So that means I've got a point of inflection at 0. And then here it was positive and then now goes to negative. So I have a point of inflection at 1. So I've got, the graph has 3 points of inflection. So you're going to say the graph of g of x has a point of inflection. If you need help writing a complete sentence, I'm pretty much just rewriting the question, right? I'm kind of starting with the question itself and then answering it. So the graph of g of x has a point of inflection at x equals -2, x equals 0, and x equals 1, because how did we know those were points of inflection? Because the second derivative of g of x changes sign at those points. Again, one sentence, no pronouns, short, sweet, to the point, precise, and concise. There you go.